we face issues like climate change or the safety of vaccines, where we have to answer questions whose answers rely heavily on scientific information. Scientists tell us that the world is warming. Scientists tell us that vaccines are safe. But how do we know if they're right? Why should we believe the science? The fact is, many of us actually don't believe the science. Public opinion polls consistently show that significant proportions of the American people don't believe the climate is warming due to human activities, don't think that there's evolution by natural selection, and aren't persuaded by the safety of vaccines. So why should we believe the science? Well, scientists don't like talking about science as a matter of belief. In fact, they would contract science with faith, and they would say belief is the domain of faith. And faith is a separate thing apart and distinct from science. Indeed, they would say religion is based on faith, or maybe the calculus of Pascal's wager. Blaise Pascal was a 17th century mathematician who tried to bring scientific reasoning to the question of whether or not he should believe in God. And his wager went like this. Well, if God doesn't exist, but I decide to believe in him, nothing much is really lost. Maybe a few hours on Sunday. But if he does exist, and I don't believe in him, then I'm in deep trouble. And so Pascal said, we better believe in God. Or as one of my college professors said, he clutched for the handrail of faith. He made that leap of faith, leaving science and rationalism behind. Now, the fact is, though, for most of us, most scientific claims are a leap of faith. We can't really judge scientific claims for ourselves in most cases. And indeed, this is actually true for most scientists as well, outside of their own specialties. So if you think about it, a geologist can't tell you whether a vaccine is safe. Most chemists are not experts in evolutionary theory. A physicist cannot tell you, despite the claims of some of them, whether or not tobacco causes cancer. So if even scientists themselves have to make a leap of faith outside their own fields, then why do they accept the claims of other scientists? Why do they believe each other's claims? And should we believe those claims? So what I'd like to argue is, yes, we should, but not for the reason that most of us think. Most of us were taught in school that the reason we should believe in science is because of the scientific method. We were taught that scientists follow a method, and that this method guarantees the truth of their claims. The method that most of us were taught in school, we can call it the textbook method, is the hypothetico-deductive method. According to the standard model, the textbook model, scientists develop hypotheses, they deduce the consequences of those hypotheses, and then they go out into the world and they say, okay, well, are those consequences true? Can we observe them taking place in the natural world? And if they are true, then the scientists say, great, we know the hypothesis is correct. So there are many famous examples in the history of science of scientists doing exactly this. One of the most famous examples comes from the work of Albert Einstein. When Einstein developed the theory of general relativity, one of the consequences of his theory was that space-time wasn't just an empty void, but that it actually had a fabric, and that that fabric was bent in the presence of massive objects like the sun. So if this theory were true, then it meant that light, as it passed the sun, should actually be bent around it. That was a pretty startling prediction, and it took a few years before scientists were able to test it, but they did test it in 1919, and lo and behold, it turned out to be true. Starlight actually does bend as it travels around the sun. This was a huge confirmation of the theory. It was considered proof of the truth of this radical new idea, and it was written up in many newspapers around the globe.